this is one of the reasons why we die. Biologic ion deformity. Like here is carbonic, an alleged possible potential whatever uh, hypothetical uh, row of hydrogens that have an OH attached to them, um, and they are going to be ionized uh, with another HO. And there's also a lithium molecule that's present next to this event of ionization, or that it becomes into the system eventually when something is positively charged. This is an electrophoric ionic electrophoresis, ionic phoresis travel of elements, and basically the lineage is going to eventually put the lithium, potentially it could put the lithium molecule attached to the OH at the string of H's. It's going to ionize, and they're going to flow into whatever molecule that really is. And if there is an ionic status, then it can mutate depending on the pathology of molecular content. So this is my goal, is to explain that things can be very poisonous, deforming. They can cause cancer this way. When we form ions to form DNA and biogenesis and different things, can for a very long time, either temporary, a long time, or a very short term, you can be very seriously damaged by chemistry. This is my goal, is to show that we are ionic to some degree, not entirely. Many of our reactions are just low level energy, like partial nuclear charge and electron force. But we do have ions, and they do travel into certain cells, especially in our intestines. We probably have them in our nerves. There's probably all kinds of different ionic stuff, because it couldn't be possible for us to constantly produce carbon dioxide and hydrogen gas and salts and minerals, and we couldn't possibly do all of this without the ionization process. So, I mean, we are somewhat ionic and somewhat neutral, but there's really no such thing as totally neutral. So, molecular energy also is very quantum. Depending on which molecule or system it is entirely, it can pertain to the whole system. Then molecules can behave differently. It's very quantum. Energy is quantum. It is a slew of particles in fields around atoms and their systems. So basically, this could go anywhere. But once you discover an ionic status that's pretty consistent, you would want to say, yeah, this could cause harm if we do this. So, or it could be beneficial if we do this. So it's a very touchy, difficult subject. But then I don't think they've gotten this far in science yet, in medicine and biology. They have to some degree, but like as to pin it all down, I don't think they're aware of these ionic statuses very well. I don't think they understand ionic chemistry very well, because it pertains to environmental variables. And it's so weird. but let's post this video. This is Biologic Ion Deformity 101. No, 102.